Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from March 2024, paper 1. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 1 says, which row shows a physical quantity and its base unit in SI system? System International. In System International, we have 7 SI base quantities and also we have 7 SI base units. Now, if you look at given quantities, current, this is SI base quantity, force is not SI base quantity, mass is SI base quantity, temperature is SI base quantity. Now, if you look at the units, unit of current is ampere and ampere is also SI base unit. Newton is not SI base unit. Gram is also not SI base unit. Degree Celsius is also not SI base unit. So the answer for this question has to be A. Question 2 says a car of mass 850 kg is traveling in a horizontal straight line. The diagram shows the two horizontal forces acting on the car in opposite directions. One force has magnitude 1200 newtons and other force has magnitude 1600 newtons. What is the magnitude of acceleration of the car? So we need to calculate acceleration of the car. So simply you need to understand F net, this is equal to ma. So in this case F net is in this direction because this force is greater. So simply we can say F net in this case will be equal to 1600 minus 1200. So this is equal to 400 newtons and this force is to the left. So simply we can say F net is equal to 400 and mass is 850 kgs. We need to find value of A. So A from here we can say will be equal to 400 divided by 850 kgs. So the final answer will be 0.47 meters per second per second. So this is acceleration. So this is how you can calculate acceleration. Quite straightforward question. The most common mistake among students is they don't understand this one. This is the single force. Single force means this is the vector sum of all the forces acting on the body. So this is vector sum. Mean this is single force that can replace all the forces acting on the body. That single force we call is resultant force. Question 3 says an object of mass m is suspended by a spring from a fixed point. The spring has spring constant k. The object is set into vertical oscillations of period capital T. Which equation for T is homogeneous with respect to base units? So what is meaning of homogeneous? Homogeneous means that each term in the equation has the same units. So this is first thing, has the same units. So this is meaning of homogeneous in a very simple way. Homogeneous. Example of homogeneous equation is V is equal to U plus AT. So we can see the unit of V is meters per second and unit of U is also meters per second. Then unit of A is meters per second and unit of time is second. So from here we can say we have meters per second, here we have meters per second. So you can see here each term has the same units. So it means this is homogeneous equation. Now we need to look at these given options and we need to find out which equation is homogeneous. Now we have K first of all. So we can say K is equal to F over delta X. F is the force, so this is mg divided by delta X. So mg in this case, unit of m is kgs, unit of g is meters per second and unit of delta x is also meter. So we can cancel meter with meter, so we can say unit of k is kgs per second square in terms of base units. Now here we have k over m. Here we have m over k and here we have k over m again. So this is k over m and here we have m over k. Now first of all we will look at k over m. If we have k over m, we will have kgs per second square kgs per second square divided by kgs. So what we will get in this case, per second square. So this is not unit of time. Per second square is not unit of time. It means k by m. We can simply cancel. So A and C, they are not possible answer. So the answer can be B or answer can be D. So let me clean this one. So these two are possible answers. So we can write down here m over k. Here we have kgs. This is divided by kgs per second square. We can cancel kgs with kgs. So here we will get second square. So we need root of this one. So if we have root of this, our answer will be equal to second. So it means this is right answer. So this is also not possible because it has no square root. And 2 pi is a constant. It has no units. So the answer for this question has to be D. Question 4 says an object of fixed mass is initially at rest at point P. The object then moves away from point P with uniform acceleration. Which statement describes the resultant force acting on the object when it is moving? So for this question we need to understand it is given to us uniform acceleration. So simply you can use F net is equal to ma. Mass is constant, acceleration is constant. It means F net is also constant. So if you look at given options, it is given to us it increases uniformly. This is not possible. It is increasing. It has to be constant. Uniform acceleration means that acceleration is constant. It is constant but not zero. Yes, this is possible answer. It is not zero because acceleration is not zero. So resultant force is also not zero, but resultant force is constant. So B is possible answer. It is proportional to the displacement from point P. This is incorrect. It is not proportional to displacement. It is proportional to acceleration. But in this case, it is constant. Acceleration is constant, resultant force is also constant. So this is incorrect. It is zero, this is incorrect. So the answer is B. Question 5 says a projectile is launched at an angle of 25 degrees to the horizontal with a horizontal component of velocity of 13 meters per second. What is the vertical component of the velocity of the projectile when it is launched? So for this purpose, simply we can imagine this is our launch point. And from this point we can draw this arrow. So this is representing the velocity of this projectile. And this projectile, it has two components, so we can use different colors. So it has one horizontal component, so we can draw here. So this is representing horizontal component, and we have one vertical component. So this is representing vertical component. We can also draw arrows here. So this is horizontal component, this is vertical component. We can also assume this velocity is v. The initial velocity is v. And angle of projection is given to us, means the launch angle is given to us, that is equal to 25 degrees. We can say this vertical component is vy and horizontal component is vx. And vx will be equal to v cosine of 25 degrees, and magnitude of this one is equal to 13 meters per second. We need to find out what is value of vy. So we can answer this question in a different ways, but this is multiple choice exam, so we have to be smart enough to answer these questions quickly. So the quickest way to answer this question is simply we can say tangent of 25 degrees means tangent of this angle. This has to be equal to vy divided by vx. And value of vx we have, so we can say this is vy divided by vx, and vx is 13. So simply vy in this case will be equal to 13 times tangent of 25 degrees. We can use bracket here. Now if we solve this one, we will get 6.06. So up to 2sf, as given data has 2sf, so we can simply say this is 6.1 meters per second. So simply you have to use tangent of 25 degrees is equal to this one, and you can find value of Vy. This is a smart way, but also you can figure out value of V from here. Then you can also find the value of Vy. For example, if you have value of V from here, so we have Vx, so you can say V cosine of 25 degrees, this is equal to 13, so you can find value of V, that will be equal to 13 divided by cosine of 25. You will get one answer here, and then you can write down Vy. This will be equal to V square minus Vx square. So we have answer of V here. Vx we have, that is 13, and if you solve this one, again your answer should be 6.1 meters per second. So this is alternate method, means alternate approach to answer this question. So the answer for this question should be B. So this is the right answer. And also, if these videos are helping you to improve your conceptual understanding of physics, please like and subscribe, because your encouragement is very important. Question 6 says a ball is released from rest at position X at time 0. At 1.0 seconds, it bounces in elastically from horizontal surface and rebounds, reaching the top of its first bounce at 1.5 seconds. What is the total displacement of the ball from its original position X at 1.5 seconds? Question is simply telling us we have, first of all, position X, we can say this is X, and we can say time here T naught, this is equal to 0 seconds. Ball is released and initial speed of the ball is equal to 0. You can also see from here. So this ball will go down, it will hit this surface, and this will bounce back, and here value of t1 is given, that is equal to 1.0 second, and it rises to certain height. So we can say here we have value of time t2, that is equal to 1.5 seconds. We need to find out this value of delta x, and area under velocity time graph, it represents displacement. So this area is representing displacement. So this is change in position, so this is also displacement. So delta x simply will be equal to the difference between these two, and this area, if we calculate this area, we have 10 here, so this is 10, and here we have 1. So this area will be equal to 10 times 1.0 divided by 2 minus this area. So we have 0.5, this is 0.5, and here we have 5, and this is divided by 2 because this is triangle. And if we solve this one, here we will get 5, and here we will get 1.25, and if we simplify, we will get 3.75 meters. So this is the final answer. So the answer for this question should be B. Question 7 says what is definition of acceleration? So simply we can say acceleration is equal to delta v over delta t, and this is a vector quantity, and this is also vector quantity. So we can define acceleration rate of change of velocity, and we need to understand velocity is a vector quantity, so it has direction and it also has magnitude. So body can have acceleration only due to change in direction, as we see in case of circular motion. Body also can have acceleration due to change in magnitude of velocity. So acceleration can be due to change in direction. Acceleration also can be due to change in magnitude. So how we can define acceleration? Acceleration is rate of change of velocity, or we can say change in velocity per unit time. So if you look at given options, option A is correct because this is change in velocity per unit time, but this is not rate of change of speed. This is only telling you one part of this one, means the magnitude is changing. So this is not complete definition of acceleration. So this is incorrect. Rate of change of velocity. Rate of change of velocity, this is telling us we have delta v over delta t divided by delta t. So this is not acceleration. Resultant force per unit mass. So acceleration is not defined, resultant force per unit mass. So this option is also incorrect. So the best answer for this question is A. So this is best possible answer. Question 8 says two balls P and Q of equal mass move along a straight line directly towards each other as shown in the figure. Ball P has velocity 1.30 meters per second to the right and ball Q has velocity 0.50 meters per second to the left. P and Q collide with one another, the collision is perfectly elastic and the total momentum is conserved. Which diagram correctly shows the motion of P and Q after the collision? So for this question it is given to us, this is perfectly elastic collision. So the smart way to answer these questions is simply we can use a relative speed of approach has to be equal to relative speed of separation, and this is only true if collision is perfectly elastic. So relative speed of approach has to be equal to relative speed of separation if it is perfectly elastic collision. So we can say relative speed of separation. So simply we can write on here relative speed of separation. Most of the time, means sometimes, most of the students, they struggle with this concept to understand what is relative speed of approach and what is relative speed of separation. So first of all, let's try to understand this concept a little bit. Imagine that we have two balls. Let's say this is ball 1 and this is ball 2. This ball has initial velocity u1, this one has u2, and after collision, ball 1 has velocity v1 and ball 2 it has velocity v2, and they're just moving to the right. All of them, they're just moving in one direction. So in this case, the relative speed of approach, if this is perfectly elastic collision, it has to be equal to relative speed of separation. So how we can write down relative speed of approach for these two balls? So in this case, approaching speed is u1 minus u2. So u1 minus u2. And how about this one? Relative speed of separation, that has to be equal to v2 minus v1. So this is how you can write down for this one. Now we will write down the same formula here. We will write down u1 minus u2. This one has to be equal to v2 minus v1. And this is only true if all of them, they are moving to the right. So as in this case, this is moving to the right, so simply we can say this is 1.30. So this is positive and negative sign here, and this is moving to the left. So we can say this is 0.50. And for the second part, simply we can say v2 minus v1. So here, if we add these two together, so we have 1.30. So this is 1.30 plus we have 0.50. So this is the final relative speed of approach. And relative speed of separation means v2 minus v1 also has to be equal to this number. Now if you look at given options, for example for this one, you can see they are moving in the same direction. It means 0.52 minus 0.22, this is not equal to this. So for this one, relative speed of separation will be equal to 0.58 minus we have 0.22. Actually, I'm explaining these things in detail so you can have better understanding. When your concepts are clear in physics once, then these questions are just a piece of cake. How about this one? What is relative speed of separation of this one? So if we write down for this one, so you see we have 0.40 v2 minus this one. So it means relative speed of separation in this case is equal to 0 because they have the same speed. So this will be equal to 0. And in this case, what is relative speed of separation? That will be equal to 0.99. This is positive, and minus we will have this value, and this is minus 0.19, and answer is not equal to this one. So it means this is also not possible. Now if you look at this one, so relative speed of separation in this case, we will have this is over v2, so this is 1.30 minus into we have minus 0.50. So in this case we will get 1.30 plus 0.50. So the answer for this question is this one. So you can follow this formula all the time, but you need to understand this is based on one assumption. Means balls are just moving in one direction, mean they're moving to the right, and then you can change these signs, mean these signs depending on they're moving in the same direction or they're not moving in the same direction. I hope no more fear of relative speed of approach and relative speed of separation. So simply what you need to do is you have to use this formula. Then if ball is moving to the left, velocity of that ball will be negative, and you can plug in values here and you can find the answer. I hope it makes sense. If this makes sense, please like and subscribe, and also if you need more help, you can join Patreon. Question 9 says a basketball player hits a ball vertically downwards with a speed of 2.4 meters per second from a height of 0.90 meters. Air resistance is negligible. What is the speed of the ball as it hits the ground? Little bit tricky but quite straightforward question. So the best way to answer this question is you can sketch first of all. So it is given to us initial speed u, that is equal to 2.4 meters per second. We can also imagine this one is the ground, so you can draw here, this is the ground, and the height from the ground is given, so we can say this is the height, so this is delta h, and the value of this one is equal to 0.90 meters. We need to find out speed of the ball when it just gonna hit at this point, or you can say when just hit that instant, what is the speed? That value of v we need to find out. So this is the question. Now in this case, as there is no air resistance, so the acceleration has to be equal to g. So simply we can use v square is equal to u square plus 2as, and in this case we will take downwards as positive. You can also take upward positive, result will be the same, but for simplicity we are taking downward as positive, so our answer will be positive. If you take up is positive, it means your answer of v will be negative because the velocity is down, so answer has to be negative, but we will be using downward positive, so answer will be positive. So this is a better way to answer this one. So in this case, value of u is given, that is 2.4, so this is 2.4 square, plus we have 2, and a is 9.81, and s is given to us delta h, that is 0.90. So we need to find out value of v, so simply v will be equal to 2.4 square plus we have 9.81 multiplied by 2 times 0.90. Simply take square root of this one, then positive value we have to keep because velocity is downwards, and if we solve this, our answer will be 4.8 meters per second, and this velocity is down. So the answer for this question has to be B. Question 10 says a ball falls through a liquid at a constant speed. It is acted upon by three forces: an upthrust, a drag force, and its weight. The liquid has a uniform density. Which statement is correct? In order to answer this question, first of all, simply we can imagine this is liquid, so we can imagine this is liquid and the ball is falling through this liquid, so we can imagine the ball is here, somewhere here, ball is falling down and the speed of the ball is constant. So we can write down first of all upthrust. How do we calculate upthrust? Upthrust is equal to weight of the fluid displaced, so we can say this is equal to density of the fluid, volume displaced of the fluid. So volume displaced of fluid times g. So in this case, as the ball is already fully submerged in the liquid, so it means density is constant because it is given to us, density is uniform, volume displaced is constant, g is constant, so it means upthrust is not changing. The second force we have the weight. Weight is equal to m times g. So in this case, m, mass of the ball, is constant, g is constant, it means weight is also not changing. The last force we have is the drag force. Drag force is equal to 6 pi eta rv. In this case, eta is the viscosity of the liquid, this is property of the liquid, and property of the liquid is not changing in this case. R is the size of the ball, mean radius of the ball, that is also not changing, and V is the speed of the ball, that is also constant. It means drag force is also constant. So these three forces are very important. You need to understand when these forces will stay constant and when these forces will change. So every year there will be question about this. So these formulae are important. You need to understand if these quantities are constant, it means upthrust is constant. If these quantities are constant, it means weight is constant. And if these quantities are constant, it means drag force is constant. So this is the main concept. You need to understand when these forces will change and when these forces will stay constant. Now if you look at given options, it is given to us drag force increases. Incorrect, it stays constant. So it has to be constant here, it stays constant. Drag force is equal to the sum of the upthrust and weight. No. So when this is falling down, if we draw the forces on this one, so you can see here weight is acting down, so the weight is down as the ball is moving down, so the drag force has to be up. So we can say this is the drag force, and upthrust is always in upward direction, so upthrust here we can draw, so this is upthrust, so this is up. So it means in this case weight is equal to drag force plus upthrust. So this is another point you need to understand. And this is telling us drag force is equal to the sum of upthrust and weight. This is incorrect. So this is incorrect, is also incorrect. Upthrust is constant within increasing depth. Yes, it is constant. So it means this is right answer. This is correct option. The weight is greater than the sum of the drag force and the upthrust. No, weight is equal to sum of these two forces because the speed is constant. So there is no resultant force. So this option is also incorrect. I hope this question makes sense. I hope this video makes sense. And I'm also hoping these videos are helping you to improve your understanding of physics. Please like and subscribe, because if you like and subscribe, that is kind of encouragement for your teacher. So I will be more motivated to make more videos for you. And also, if possible, please share with your friends. And also, if you have any questions, you can leave in comments and I will try to answer as soon as possible. And if you're looking for extra help and more guidance and more resources, you can join Patreon. See you next video.